All right. Okay. Hi, everyone. I'm Liz. I run Course Report, which is a resource for choosing the right coding bootcamp for you. If you're watching this video, you probably know that. Today, I'm joined by Marnie, who took the data science bootcamp at Thinkful. Thank you for joining us, Marnie.
Hi.
We get questions all the time about what you can actually build during a boot camp, because I think a lot of boot campers start by like doing Code Academy or making little tweaks to HTML, maybe like building a clone of an existing app, but they want to kind of take it to the next level and be able to build something and deploy it, something original that they could add to their portfolio and show to employers. And Marnie, I've heard that your final project was pretty neat, so I'm really excited for you to share it.
All right.
Okay. All right. So can you share your screen now and tell us a little bit about your project?
Good question. Yes, I'm so excited to show you this. And tell me, can you see the yellow slide?
I can. Okay, cool. Automated face shape detection and hairstyle recommender. This sounds serious. Talk us through it.
Okay, so my mentor had asked me, find something that's applicable that you could go out and sell. You know, don't do like Pokemon and how you find the best one or whatever, or don't do like weird things that just no one would ever relate to. But something you're passionate about, something you could sell. So I don't know why, but in my head, as soon as he said it, popped in the times that I go to like the hair cuttery or even like, you know, Dry Bar, which is like a super cool, like women-owned entrepreneurial company. And the hairstyle and taking care of yourself is like such an important part, but like there's a lot of, I don't know, uncertainty around, you know, what looks best on you. So I was inspired by that. Is this something that women could use, or even stylists and salons could use to help their customers? So that's what this was about. The first step, so I'll tell you again, the purpose is really that this is an industry that's very large, $20 billion, and it's really about women. To be honest, you know, most hair care is about women. And now you have a lot of women in the workplace that are high earning. They don't have time to figure all this stuff out. So I thought it would be great to automate it in a way that kind of meets them in that high tech, on the move kind of style. Right now, women are spending $55,000 for their hair in their lifetime, and every week spending 2 hours styling or caring for it. So you know it's really important to them. And so one of the first things you need to know, like what hairstyle is going to look good on you, is to know like what is your face, right? Like how does it shaped, and what hair would look best on you? So if you go to like fashion magazines, a lot of times they'll just recommend, hey, you know, do long if you have a short face, do short if you have a long face. And how do you know what kind of face you have? So there's also a lot of like rules about, oh, well, if this is too wide, you know, so there's a lot of like conflicting ways to design like what face shape you have. So I thought I would automate that so that people could just know once and for all what face shape they have. So I started with my customer in mind. Her name's Jacqueline. She's a very new mom, and she's a successful journalist. She is now going to the USO Gala with her company. And so she's really excited for this night out with her husband, Nick. She wants to look her best. So the first thing she does is she hops on her phone, she makes a salon appointment, and she really wants to figure out like what flattering styles should she find. And so confronted with all those choices that you can find, like if you just like Google like best hair for for women, as you can see on the left there, she decides to try my app, which I've named What's Her Face. And What's Her Face really allows you to do this. You just upload your picture. It runs the face shape classifier, in which case oval, and then it recommends styles. And you can see here that there's only 2, but if you look at the buttons at the bottom, she can scroll across and see a couple of different styles that are best for her. And then she can use these buttons, the little favorite buttons, to decide if she likes one or if she doesn't like one, so that her recommender will, you know, begin to tell her similar styles. Then she decided that those beachy waves of Allison Williams would look best on her, so she picked those for the night. So that's the big picture on the app and the project. And for like the Thinkful people and the coding people in the world, the back end of this deck is really about the pipeline and how I did it. And so I can go through that very quickly. I know we only have Okay. So the hardest part of any project is having data. So I first collected and classified many, many image samples of women with different hair styles and different faces. Then I created a feature extraction. Then I obviously tested and trained my data and ran a bunch of different models, because that was part of the assignment, and then developed a recommendation system as like icing on top. So what you can see is I built this little spreadsheet where I was trying to keep track of like all the different sites I went to and like what face did they actually have. So, sometimes you would have where they thought Emma Stone was round, oval, and heart. So I didn't use her because she wasn't a definitive data set. But for example, Emma Watson or Eva Longoria, you can see that there's like a semi like consensus around her face. I went to 22 different websites. I had 234 celebrities that I started working with. So you can imagine writing some scraping and Google scraping and stuff was really useful here and allowed me to do this very quickly.
So you build that initial data set and then
Yes.
are kind of using that to train future data sets?
Yes, which is crazy. I mean, most of my time was in this. And I always give people advice. I'm like, make sure that your data set is unique, because while Kaggle has some great data sets, everyone can has access to them. You can only be unique if your data is unique,
Very cool.
So I had this data set I validated that, did I have enough information? Did I have enough unanimous kind of consensus towards the face shape so that I could use it as sort of the ground truth? And then you can see the face shapes that I had. I had heart, I had long, I had oval, round, and square. And then the more like distinctive the face shape, if you think about it, like oval and long are kind of similar. Heart's kind of a little bit of a mix of a couple of them. But when someone had a round face or a square face, there seemed to be a little bit more consensus. So you'll see when you talk about confidence in this model, like that they actually tend towards these more extreme face types, which makes it difficult. Any kind of model that you're doing to classify things, the confidence in your original data set is going to have an impact on how stable your model is. So as I said, I used Google Images. I scraped all these. I wrote a little query that scraped all of these images and put them in folders. And then the model was able to use the folders. So I processed each image, which was really fun to learn how to do. Is you really have to, first of all, there's a face recognition package that you can use that I'll show you in a second. I also rotated, aligned, and cropped the images. And then I generated features associated with that. And then you can see that I developed a data frame. So here's what I mean by rotate, crop, and align. I want to make sure that when it looks at someone's face, it knows like that this person's face is tilted. It's going to throw off the measurements. So I made sure everyone's face looked exactly at me, which is actually really funny. If you look at this page, these are the face images of these women, but like all superimposed on top of each other. So these were, let's say paparazzi photos that they had all different, angles to their face, but I was able to align them all on top of each other. They all fit exactly in this little square box, which was so cool to learn how to do. And I think it's like a really neat part of image recognition that I didn't know about.
How did you learn how to do that? Like, did you know that this is how you would kind of analyze these images, or did your mentor at Thinkful help with that kind of planning, or how did you figure it out?
My mentor at Thinkful definitely had a lot of influence on these nuances that I wouldn't have thought this made a difference, because I'm so busy trying to just like figure out how to Google scrape. And he would be like, well, have you thought about this? And then either he would send me a link, or you can just Google like how to align images, because this is like very common code. I doubt I wrote it like from scratch in any way, but like really just, used other people's to say, okay, this is what I want to get out of it. But yeah, it was very collaborative. It was really interesting. He really took a lot of interest in my project and really thought it was a pretty neat project, especially as I started to really enhance it. So he was a great asset for sure. I don't think you could do this without a mentor, to be honest. So the feature generation library I was talking about basically finds these 68 points, which is so cool that our face has these points. And then if you think about it, the measurements between these points is unique on everyone's face, whether it's like an angle, a length, a width. And then my mentor and I discussed, well, how do we figure out the person's forehead? Because like if their hair is like, if they have bangs, I can't tell where their head ends. And if they don't have bangs, then they look, then I can figure out where their forehead is. So we couldn't really use like their hair color to determine that. So what we did is we just like used our own faces to figure out that there's sort of a point where your face is like sort of cut in half, and we just used that point and doubled it. So it was really fun to like think about, okay, sometimes you have to generate data that's not even there, and how do you do that? So this was really cool to look at these different facial, and you can see that when you break down every face width, face height, which I've defined above, it's a really relatively normal distribution of all of our faces, kind of like fall pretty similarly if you average them all together. But when you start to compare, I give you two examples here. If you look at a heart and oval, which as I said earlier, hearts and ovals are not super definitive between them. And you can see that the width of their face there's kind of a big, strong overlap. So the p-value is not very good there. But on this one, for example, the round and the long. So if you can think about it, if someone has a round face and a long face, you do not confuse those. And you can see that the p-value and the averages really are very separate when you talk about the width. So that's the ear-to-ear width. So this just kind of proves out like what you're seeing in the data and what kind of common sense would tell you about someone's face. And then I've kind of extrapolated, okay, here's a heart and a long, don't look that different, right, to the human eye. But these two faces, very, very different. So I just wanted to kind of illustrate that for the audience. Again, I've kind of gone through, I mean, some of this is more for like the purposes of like my project, so it doesn't add a ton more information, but the widest face are the round, the most narrow are the long. You can see that with this box plot. Some of the ratios, you can see that the round face has that lowest ratio. So think about it, a circle doesn't have a high ratio between height and width. In fact, they're the exact same. So the closer to 1.0, the more kind of round a face is. And you can see that that is obvious with a round face. This one's cool because you're talking about like this very minute difference between mid-jaw and jaw. I think that's where I found the heart was starting to kind of pop a little bit. Again, the model takes all of this stuff into consideration all at the same time. So it's not like one of these metrics matters, but I thought that was really interesting that that little kind of piece between your jaw was what made a heart face look like a heart face. One of my favorite, most difficult things I did was average every single shape, putting a different dot. So all the round faces were these orange dots if you just took every celebrity's round face. And you can see just how much shorter her face was, you know, especially down here at the chin. And that was just kind of interesting to look at the kind of aggregate of all those faces and just the points on top of each other. The models I constructed, again, you know, we were asked to attempt several of them. So I attempted a bunch of them, some different, you know, neural networks, gradient boosting and all that, and kind of came up with that the KNN model really performed the weakest, but my neural network performed the best on 4 out of the 5 shapes. Showing here like a confusion matrix, you can see my friends, the oval heart overlap is still strong here. You can see that's where I had the greatest error, but not a lot of error across the board, just a couple handful that are misappropriated here. I ended with what I would consider an extra of having a recommender system that allowed the user to select one that they liked. And like I seeded it with points because this was like sort of random. I started everybody with, you know, 75 points, 20, whatever, random number. And then if you put a heart, then you gained 5 points. And if you put like an X, you would lose 5 points. And so the next time you ran it, that face, which was a 75, now I'm giving it an 80. And the one that was up here on page, the 6th one is now gone. So these, sorry.
So then like not only is the user able to identify their own face shape, but then you're actually giving them recommendations on their styles that go with that.
Yeah, so, sorry, I didn't mention that. That's what, remember Jacqueline was considering those different faces. And so she could choose from these and she could keep running it until she found one she liked. Just like if in Netflix where you like start to say like, oh, I've seen that movie and I hate it. It'll just like rerun and give you another suggestion. So, I mean, this is far from a Netflix recommender, but it's meant to do the same thing. And then to store this 80 value, so the next time someone like Jacqueline comes in, it shows her this set, if it's appropriate, and starts to drop off the last one that's least recommended.
So cool. So neat.
And then just the last slide, because I thought this was funny, I just asked a few friends what they thought of it, and including my mother, and everyone seemed to think that this was a pretty cool app to use for their hairstyling.
I agree. This is a problem that I have talked about so many times before, is that you always get these recommendations for your face shape, but it's really hard to know what your face shape is unless it's extremely obvious, like that you have a long or heart-shaped face or whatever. I've never known what my face shape was. So this is so cool.
Well, thank you. Yeah, I walked around for a few months looking at everyone's face a little more intently, and I just saw Mamma Mia too, and I couldn't stop thinking about Amanda Seyfried's face shape because she was my alphabetically first name, and I must have looked at her picture 5 million times over 2 months. So
very heart-shaped.
Yeah, she's got a great face.
Well, yeah, I mean, you solved like a very real problem using data, which is so neat. Could you talk a little bit about what in this project you like could not do before with your very stellar Excel skills? Is there like, what did you learn at Thinkful that you put into this?
There's nothing. You know,
everything?
there's nothing in here. There's that one little Excel snippet that I'm like sort of half surprised I put in here because, my mentor was really good. He's like, Marnie, if Excel's going to make something easier, just do it. Like, don't force yourself to be like Pythonic in every way. Like, if this will make your life faster. So yes, this grid could have easily been built in some sort of fancy way, but like for example, this is probably the only thing. And I feel like from a deck perspective, like putting together a deck that tells a great story is a little bit of something I've learned before. So if you're not great at that before Thinkful, that's not what they're going to train you on. So kind of being able to come up with like the journey of this Jacqueline person or whatever, that isn't really what they teach you. But literally every other technical component of this, I would have never been able to do without Thinkful.
So most of it was done in Python. Any other, well, actually, so aside, I guess you learn a certain amount in the Thinkful curriculum. Did you learn anything by doing this project that was like on top of the curriculum where you had to go outside of what Thinkful taught you? Like, could you give an example of that?
Yeah, all the sort of image recognition, facial recognition, I taught myself. I actually tried to use, like I said, Docker to kind of run these models because they're so big and the data was so big. But that was something you wouldn't necessarily learn. That's why I like these projects that you have to come up with yourself, because if they design projects, it's just in line with what they've taught you. When you have to come up with your own project, first of all, there's no answer key. And then you have to sometimes Google for 2 days until you find a way to like straighten up someone's face or, make a image, do this or how you do these face shapes and stuff, or like even this little average thing. The hardest thing I had was I couldn't make this darn legend. I think I ended up making it in PowerPoint, but but like I just struggled with like how to make the legend work on these overlapping points. So I would say like it's probably 50-50 your last project. If you can go 50 with what you know and learn 50% of new skills that are sort of applicable, I think that would be really fun because that really helps you kind of solidify that you know enough to go out and on your own and kind of find new information, which is what you're going to have to do in the real world,
Yeah. So is this live now and can people use it?
No, I never deployed it, but I'm looking for a buyer and I think I just have to get on that, but it's, I would love to do something real with it one of these days.
I feel like Drybar could totally incorporate this or a similar app. So
what's cool is Drybar has like a very specific like menu. I mean, it's kind of a bar theme. So I was thinking like, how cool would it be if it would like just basically told you which of their menu hairstyles you should get? So I agree. They should be my client, but I haven't.
Okay, so Marnie, you went into Thinkful to like build your skills, not to get a new job or to change careers necessarily, but more from like a personal motivation and kind of building your skill set. Do you think that you like met that goal? Is that you notice your skills have improved or changed? Could you talk about that a little bit?
1,000%. I mean, I'm kind of getting known for some of the work I'm doing. I work in like an agency, so we have, very different clients all the time. And sometimes it's new business, and really the creative ideas are what gets you ahead. Like it's not status quo and you can always be challenging yourself. So I've been part of some really big new business pitches. And I've even done some stuff for like, just clients that we already have and just thinking about new and different ways. I led an AI workshop last month for one of our biggest clients, and there was no way I could have done that without Thinkful and the confidence and the knowledge. The ability to sort of know what I'm talking about, but also know I know what I'm talking about was also really instrumental.
Cool. Well, thank you so much, Marnie. That's been really helpful. It's so neat to see what you were able to actually build throughout your time at Thinkful. And thanks for sharing your story. This was fantastic.